hi guys. Hi Xander. Hi Edwin. Welcome
Hello,
to
thanks for
.next.
having us.
Yeah,
Thank you for having
great.
us.
Thank you. And also, hi Yuri. Yuri is our expert today. He is from Kazan, and he is organizer of .NET meetups in Kazan. How's the weather there, Yuri?
Well, it's raining a bit.
Oh, the same in St.
That
Petersburg.
sounds like the Netherlands.
Yeah.
Okay, we are all on the same page. Yuri, just wanted to ask you, you have such an interesting hobby, listed in your biography on .next site. Just wanted to ask you, do you have some time still to do some coding?
Well, coding is a lifestyle, and hobbies is a hobbies.
Okay, so I think the answer is yes. Okay, and Edwin, I just, and maybe Xander either, I just wanted to ask you that both of you guys have, you're kind of leads and organizers in Dutch communities related to Asia, to .NET. Just wanted to ask you guys how the life of communities changed after, this COVID pandemic and this stuff. So everything is online, I think.
Yeah, most of it is online. So I guess that one of the last in-person meetups in the Netherlands, I think, was the Dutch Azure meetup that we did. It was basically also on Dapr. So that was in March of last year. But for now, everything is online. So we're going to do sessions like this, and we're sitting behind webcams all the time. It's a bit of a strange experience, but we're getting a little bit more used to it every day. So yeah.
Yeah, and it's more difficult for some things than for other things. For example, we have a video podcast channel together, which is called on Netflix, and we used to record those in person, and now we record them via Zoom. And that's very easy. That's a really small transition. But with the meetups, we like to organize these really hands-on workshop type of meetings. And those are much harder to virtualize than just a podcast. Yeah. So I'm really hoping that we can all get vaccinated soon and just be done with all the virtual stuff and can go back to some more hybrid type events again.
Yeah, I totally agree, totally understand it. Guys, just wanted to ask you, why did you select this topic, Dapper? Why do you like it so much? Why do you like to describe it for all the guys?
Yeah, well, we came into Dapr when it was still in preview, and we thought it was very interesting technology. So we build a lot of microservices applications for our customers with info support, and we often have a lot of effort that we have to put into abstracting away all kinds of infrastructural components like message brokers or state management or stuff like that. And that's exactly what Dapr can offer you, as we will show in this session. So it is very interesting, and I think it will be very useful for people building microservices. So that's why at least I was very interested in it and started looking into it. And I wanted to become an expert on Dapr for the people to help them. So that was my incentive.
Yeah, if I can add to that, Edwin, I really like the promise of Dapr, right? Because it promises that you as a developer can really focus on your business logic, on the application that you're trying to create, and not have to deal with all these infrastructural concerns. And if that really works out in the coming years, and we'll have to see. We're still at an early 1.0, but that's really useful for us because our clients want us to deliver business logic and stuff that does something real for them, that adds value to them. And all this stuff, this infrastructural stuff, problems you run into with microservices that you need to write technical code to solve. That's stuff that you have to do, but I'd rather have some framework like Dapr take care of that for me.
Yep.
Okay, great. Yeah, just small reminder for our spectators that, guys, if you have some questions during the talk, please write them to the Telegram chat that you can find right near the player. And Edwin and Xander would be happy to answer them during Q&A session. And even if we don't have enough time during Q&A session, we could go to the Zoom discussion zone and to answer them there. Okay, guys, thank you. I'm really excited about the talk. Maybe we could start.
Yes, thanks for the introduction. So I will take it away then. Welcome to this session. Thanks for joining us for this advanced Dapper session. Well, we did already the introduction, so you already know us. So let me just dive into to the slide. So what's the agenda for today? What we'll be talking about in this session? First, we're going to do a little Dapper recap. Just like we said, it's an advanced Dapper session, but we want to give some kind of a recap to make sure that we're all on the same page. After that, we're going to look at the traffic control sample. This is a sample application that we've built based on microservices that we use for our sessions. Then we're going to look at how to secure your application on a Dapper level for production purposes. Then we're going to look at how Dapper integrates with a couple of Azure services like Logic Apps or API management. And finally, we're going to look at how you can extend Dapper. So we're going to look into how to do that. So like I said, this is an advanced Dapper session. If you want to be more hands-on, so if you want to do some stuff yourself, we have a workshop that we're going to do tomorrow on .next. So make sure that you be there, and then you can start working with the traffic control sample application, but then implement Dapper yourself. So that's a hands-on workshop that you can do. So let's dive in, the Dapper recap. So what is Dapper? Well, actually, Dapper, like we said in the introduction, offers you a set of building blocks that will abstract away a couple of infrastructural capabilities that you often need in a microservices application. And you see the list of building blocks in this slide. So if we look from left to right, you have service-to-service invocation for invoking services, other services within your application, state management for storing state, pub/sub, resource bindings. Well, I won't go into all these building blocks, but you can see there's a lot of capabilities in there that Dapper offers you. And what is really cool about Dapper is that all these capabilities are available using an HTTP or gRPC API. And this is a very important part to grasp if you look at Dapper, because this means that you can use Dapper from basically any environment that you are using. So if you're building an application in Go, or you're building a Node.js application or Java or .NET application, basically from every programming language, every platform that you can use HTTP or gRPC from, you can leverage all these building blocks. And that's the only API that you then need to know. So that's really important to understand. And then, like I said, Dapper also integrates with a lot of other frameworks, and a couple of them we're going to handle in this. We're going to look at in this session. So this is basically the stack that we're going to look at, and then we're going to focus on Dapper from that perspective. So how do you run Dapper? Because this is also a very important concept to grasp. It uses a sidecar pattern or sidecar architecture. So what does that mean? Well, basically, if you run your application code, which could be a microservice or some other part of your application, then Dapper will also start an additional process, basically, on your machine that runs alongside your application. And then your application code communicates with the Dapper sidecar over this HTTP or gRPC API. So that's really important to understand. Well, there's multiple hosting models within Dapper. This is the self-hosted variant. So you run your application code and Dapper is started alongside of it. It also supports running it in Kubernetes. And this is a really cool way of deploying Dapper, because within Kubernetes, you have the notion of a pod, and within a pod, you can have multiple containers. And these containers can communicate to each other. So that's a really cool way of implementing this sidecar pattern. So this is the hosting model. Let's look at a little example of how this then works in practice. So let's say I have an application running with several services running in Kubernetes. So I have here a service A. We are not very creative when it comes to naming stuff, but excuse me for that. But service A is a pod. It has a container with your application code, and it has the Dapper sidecar container. And Dapper also has a kind of a control plane available within Kubernetes for injecting these sidecars. So you can just configure that. And we're going to look at it a little bit more later on. So what happens here, let's say that this service A wants to store some key value pair in an external state store like a Redis cache. Well, then what you can do, you can call the Dapper API and use the state management building block. And you can configure this state management building block using a configuration file. So it's all declarative. You declare which kind of a service you want to use. And in this case, you might configure a Redis cache. So then we can use the Dapr API to store key value pairs in Redis cache. And so this one of the advantages here is that you don't need to learn the Redis API. You can just use the Dapr API, and you can use Redis as the underlying store. Even more cool is that if you change the configuration here for this building block, and for instance, because you want to use a Cosmos DB as your state store, your backing state store, then this is the only thing you need to do. You change the configuration for the Dapr sidecar, and then it will use Cosmos DB, and you don't need to learn an additional SDK or library. So that is one of the main advantages of Dapr. Another building block that you saw is service-to-service invocation. So if service A would like to call service B within the application, it could just do an invoke call on the Dapr sidecar. It uses then the service invocation building block, and then the service invocation building block will search for the other application, in this case service B, and it does that based on a unique ID that you specify, and then the Dapr sidecar communicates with the sidecar of the other service and then forwards the request. So this is basically how that works. So this is an example of two of the building blocks, but there are lots of others, and we're going to look at the traffic control sample in a minute to see how we use these building blocks. So what is traffic control? We've talked about it a little bit before. So this is something that we actually have on the Dutch highways. I don't know how it is in other countries, but I have seen them in America before, but I don't know how it is in Russia. But we have a couple of places in the Netherlands where we have these kinds of speed traps. So there are a couple of cameras at the beginning of a stretch of highway and at the end. And then these cameras register your license number. And once you have exited because you drove under an exit cam, the system that will take these pictures can calculate the speed, so the average speed that you drove. And if this is above the speed limit for this highway, you will automatically get a fine on your doormat. So that's completely automated within the Netherlands. So what we did was we built a small simulation based on a couple of microservices, and this is what the solution is, kind of a big word, but this is what the application looks like. So we have a camera simulation, we have a traffic control service that actually simulates the cameras, the entry and the exit cameras. We have a fine collection service that is responsible for sending the fine to the driver of a speeding vehicle. And we have a vehicle registration service that has all the information of all vehicles and their drivers. And how does that work? This is a quick sequence diagram of how this application works. So we can call from this camera simulation, we call into the entry cam endpoint. This will simulate a vehicle driving under the entry cam. It will store the state. It will then, after a random interval, send a vehicle registered message to the exit cam. This will simulate an exiting vehicle. And then we can get the vehicle state back. And then based on the timestamps of the exit and the entry, we can calculate the average speed. And then if we have, if it is over the speed limit, we will send a fine using the fine collection service. And when the fine collection service gets the command to send a fine, it will get the information of the vehicle and the driver from the vehicle registration service and then send the email. So this is basically the sample application. What we did, because this is basically all HTTP, but this is all tied together, and it's basically the start of the application. So what we did is we Dapperized this application and used a couple of Dapr building blocks in it. So this is how this works. What you can see here is that the camera simulation will not have a Dapr sidecar. It will just be a .NET Core application because this is all .NET Core, but all the other services have Dapr sidecars. And where do we use these building blocks? Well, first of all, if the fine collection service needs to get vehicle information, it will do that using the service invocation building block. So it uses service invocation to call the vehicle registration service. The traffic control service, when a speeding violation has been detected, it will send a message using pubs up, and it will use RabbitMQ as the message broker to get this speeding violation to the fine collection service. The traffic control service will store the state of each vehicle, so the entry and the exit parts. It will store it in a Redis cache using the state management building block. We will use an SMTP binding. That's also part of the building blocks to send an actual email using an SMTP server. We send from the camera simulation to the traffic control servers. We will send MQTT messages using an MQTT broker. In this case, we use Mosquito, which is a lightweight broker. And for that, we use an input binding, which is one of the building blocks. And then finally, because we need to securely store the credentials for connecting to the SMTP server, for instance, we use the secret management building block from Dapr, from the Find Collection service. So it's quite an elaborate set of building blocks. And for now, it is important to understand the services that are there, because we're going to use these in the samples that are coming. But if you want to work with this, like I said, then join us for the workshop tomorrow, and you will be implementing this all yourself and learn along the way how you can leverage Dapr. This all runs in Kubernetes. So what we're going to show you runs in Kubernetes on our machine using Docker Desktop with the Kubernetes enabled. And with that, I think I will pass it on to you, Sander, to start talking about how to secure this whole application on the Dapr level.
Yeah, so thank you, Edwin. So
I'm going to stop sharing my screen.
Exactly, and then I can share my screen and we will be at exactly the same place in the presentation. Okay, so yeah, as Edwin has just shown you, traffic control is this example of how you can use those Dapr building blocks and combine them and use them in an actual application. In the coming section, we will look at some measures that you can take to secure your Dapr solutions if you want to actually run them in production. And if you look at the solution diagram, we can distinguish different areas to harden. So, for example, we can secure the communication between those sidecars. But we can also look at the communication between the sidecars and the Dapr components and how we can secure that type of communication. And then finally, we also have communication between the Dapr sidecar and the applications or the services. So all of these areas need to be tightened down and need to be hardened if you want to run this in production in a safe way. So let's start with sidecar to sidecar communication. So here's an example of the Find Collection servers calling the vehicle registration servers. So in the traffic control sample, this happens when somebody drives way too fast and a message is sent to the Find Collection servers, and then that service needs to reach out to the vehicle registration servers to get some more details on the vehicle owner. And it uses the service invocation building block for that. Now, the first thing to note here is that Dapr includes automatic mutual TLS or two-way TLS. And that's a technique that encrypts the traffic between the sidecars. And this feature is on by default. So if you don't want to have it, you have to explicitly turn it off. And it offers two benefits. So first of all, there's now two-way authentication. The client needs to prove its identity to the server, and the server needs to prove its identity to the client. And then when that succeeds, a secure channel is encrypted between those two sidecars, and then all the traffic across it is encrypted. Now, the other thing you can do when you use service invocation is to tighten things down using access control policies. And a access control policy specifies which applications are allowed to call a sidecar. So, for example, in this scenario, I can configure it in a way to make sure that only the Find Collection service is able to call my vehicle registration servers. Now, to support all these capabilities, Dapr includes a system service called Dapr Sentry. And Dapr Sentry is basically a CA, a certificate of authority, that generates the workload certificates for the Dapr sidecars, for the Dapr instances. And these workload certificates are then used to create the MTLS channel. Now, that workload certificate also includes a SPIFFE identifier. And SPIFFE is a CNCF standard. It's a standard for providing strong identity to a workload. And a SPIFFE identifier consists of a couple of different parts. And in Dapr, you can see the format here on the top of the slide. In Dapr, we first need to specify a trust domain. So a trust domain is a logical grouping of applications that trust each other. So by default, they will allow access to applications within the same trust domain. But if an application outside the trust domain tries to make a call, it's denied. And then we add to that the namespace of the Dapr application and the application identifier of the Dapr application. And if you put all those parts together, then you have a unique identifier for each Dapr application in your solution. So you can now identify it uniquely and you can assign rights to it. So now that each app has that strong identity, let's look at an actual example of access control policy here. So in this example, we've got the fine collection service, the traffic control service, and the vehicle registration service. Now, as you already saw in the previous slides, the fine collection service needs to be able to call the vehicle registration service. But the traffic control service doesn't. So the traffic control service is the service that takes the moment of entry and the moment of exit, and it calculates whether or not a fine should be given. And if that fine is given, it will talk to the fine collection service, but it will never talk directly to the vehicle registration service. So we can create an access control policy to make sure that only that fine collection service will be able to talk to the vehicle registration service. And more specifically, this is the URL that it needs to call. So it needs to be able to get some vehicle info based on a license number. Now you specify access control policies in a Dapr configuration file. So each Dapr service or Dapr application, it's a bit synonymous, those terms. So you can either call this vehicle registration service a service if you look from it from a microservice perspective, but in Dapr terminology, it's called a Dapr application because it has its own sidecar. So each Dapr application has a Dapr configuration file, and in that configuration file, we can, amongst a lot of other things, specify our access control policies. And we do that in an access control section. And by default, I'm just denying everything that comes in. So that's basically safety by default. And then I also need to place this vehicle registration service in a trust domain. So I'm using the trust domain public here. That can be any string you want. Public is the default. And now I can start specifying some specific policies. So I want to specify a policy for the fine collection service because that's the service I want to give access. That service should be in the same trust domain, and it should be in the Dapr traffic control namespace. So if a request comes in that matches those three settings, then again, I'm still denying it because I only wanted to be able to make that cat call on the vehicle info endpoint. And maybe the vehicle registration service has some other endpoints that I don't want to be able to be called by the fine collection service. So I'm still denying it. And then I can dive even deeper and configure it on an operation level. So here I've got a filter for the vehicle info endpoint. So if that matches and the HTTP verb also matches get, because I don't want to have any post or put functionality on that endpoint, then and only then allow that call to go through. So as you can see here, you can use some really fine-grained configuration to set up exactly which services are allowed to call which other services. So that's really nice, I think. Let's switch gears a little bit and look, instead of Sidecar to Sidecar, let's look at Sidecar to component. Because all Dapr components are namespace, so that means that an application can only access components in the same namespace. But even then, you may want to limit access further because not all components which we use in the Dapr traffic control sample are needed by all of the services running in that same sample. So for example, the traffic control servers, it uses the Dapr state management building block because it stores the timestamps for the entry and exit events. It stores that inside Redis cache. And it does so by using this state component configuration file. So you can see it's named state store, and it's in the Dapr traffic control namespace. And of course, in a component configuration file, you also need to add some further details on how you can then actually connect to a backing store. So here you can see in the spec type that we selected Redis as the backing store, and in the metadata, you can see the exact connection details to connect to that Redis instance. What's also nice to mention here is that if you look at the Redis password fields, that we don't have a plain text password in there, but we instead use a reference to a secret. So under the hood, that uses the Dapr secret management building block to get the actual value for the Redis password. Because these types of configuration files you probably want to store in a version control system, and you don't want any passwords in there. Now, if we look to the find collection servers, that service doesn't use the state management building block, and it doesn't need access to that Redis database. So what we can do to tighten that down is to add this scope section to the component configuration file. You can see it all the way down in the state component configuration. And that's simply a list of application identifiers, I should say, that we're allowing to use this component. So now when I try to use this component from the traffic control servers, everything is fine, that works. If I try to use it from the find collection servers, access is denied. And for some building blocks, you can take this a step further even, and you can, within the scope you already have of having access to the building block, you can tighten it down even further. So for example, if you look at pub/sub topping scoping, we use pub/sub in the traffic control sample, and we use it specifically to publish collect find messages from the traffic control servers to the find collection servers. So that's loosely coupled. So in this case, the traffic control servers should be able to publish messages to that RabbitMQ topic. And the find collection server should be able to subscribe to the messages. And they both should only be able to interact with the collect find topics, because maybe this RabbitMQ cluster that I'm using here is like, maybe it's a kind of service bus in my organization, and there are all kinds of topics on that same infrastructure that are used by different applications. And I don't want to give my application access to all of those topics. So I can tighten it down by, again, creating a component configuration file. And first of all, just specifying which are the allowed topics that my application is allowed to use. So in this really simple example, I'm only allowing my application to use the collect find topic. And then with publishing scopes, I can define what the operations are that my different services can perform on that topic. So what you see here is that I'm allowing the traffic control servers publishing rights on collect find. And I've also included find collection servers in that value, but I'm setting it to a blank string basically. So that means that the find collection servers does not have publishing rights on that collect find topic. And as you'd probably expect by now, for the subscribe side, it's basically the same. So you define it using subscription scopes, and here the traffic control service is left blank, so it doesn't have any right to subscribe to the topic, whereas the find collection service does. So that's even more fine-grained control that you have. For secrets, it's a bit of a similar story. So Except maybe I should note that for secrets, you use again the Dapr configuration file. So you don't specify this in the component configuration file, but you specify it in the more general Dapr configuration file. And there you can specify which services are allowed access to which secrets. So in this Dapr configuration sample that you see here on the right, I've got a secret section with some scopes in it. And as you see, we are using Kubernetes here. So this is basically a wrapper around the Kubernetes secret store. By default, we are denying everything. And then we are allowing a secret for connection string to be retrieved from the secret store. So this is useful if you have if, for example, you use the Kubernetes secret store, you use something like Azure Key Vault or HashiCorp Vault. There may be a lot of secrets in there, but your application only needs a couple of them. Then using this configuration, you can deny access to all of those secrets by default, and then only allow access to the couple of secrets that your application really needs. All right, let's switch gears again and let's look at the application to Sidecar communication. So we've talked about Sidecar to Sidecar security, Sidecar to component security. And by default, if we're at this level, by default, the Dapr Sidecar relies on a network boundary to limit access to its public API. Right. So again, if you look at Kubernetes, these two things will run together in a Kubernetes pod. And usually the pod is considered a security boundary. But what if you want to actually expose that Dapr Sidecar API outside of your cluster? Or maybe you're concerned about other containers running in that same pod maybe having access to the Dapr Sidecar that you don't want. Well, in that case, you can enable API token authentication. So what happens here is that you generate a token, which can basically be any string, although they recommend that you use JOT tokens to be compatible with possible future features. And then you store that API token in Kubernetes or in a secret store somewhere, and you configure it on both your application and your Dapr Sidecar. And then a request to the Dapr Sidecar will only succeed if that request has a valid API token attached to it. And otherwise, the Dapr Sidecar will not, or will send back an error and will not do the request. You can also do this the other way around, because in some scenarios, especially if you look at building blocks such as the pub/sub building block, then it's actually the Dapr Sidecar that calls into your application. And again, using an app token, you can further tighten it down. So with the app token, it's basically the same story. You create a secret, you configure it on both your application and the sidecar. And then with every request that the sidecar makes to your application, it will include that app token. And then in your code, you can check that that app token is valid and you can allow the request. So those are basically the security measures that I wanted you to know of. It's really, I think there's a lot of flexibility in how you want to set this up, and a lot of great controls for really tightening it down in production environments. So with that, Edwin will now tell you about some integration with some other Azure services. So let me stop my screen sharing, if I can find a screen, because I've got a lot of stuff on my displays. Yeah, found it.
Yes, and I'm sharing my screen again.
Yeah, I can see it.
Yes. So here you see again the whole Dapr ecosystem, so to speak. And let's look at how you could use Dapr using logic apps and API management. So first of all, API management. API management is a service that we all know and love, of course, in Azure, that you can use to create publishing and managing APIs. That could be APIs within your organization or to external third parties. For a long time, Azure API Management was just a service that you could use in Azure, but since a couple of months, I think, you can also run a self-hosted API management gateway. That's a Dockerized gateway. So if you can run Docker containers, you can run it. And you can run it anywhere you want. So you can also create an API on premises in your own data center, for instance. And then the latest addition to that is that Dapr can integrate with the self-hosted gateway. So then you can use Dapr in combination with API management to, call Dapperized services, so to speak. And the building blocks that you can use from this hosted gateway now, maybe it will be expanded later on, but for now you can do service invocation, PubSub, and bindings. So how does that work? Well, let's look at a situation here. On the top in this slide, you see API management with two APIs, /customer created. And then at the bottom, we see a self-hosted API management gateway that is running, let's say, on premises in a data center. And this uses a customer service, so it has an API that exposes this customer and customer created endpoint, and it calls into that customer service. Well, what you can do with Dapr is that you can add, if you register this self-hosted gateway in Azure, so you have to still create the API in Azure using the management console or using the CLI, then you register the self-hosted gateway with API management, and then you can push the policies from API management to your self-hosted gateway. And if you do that, these APIs become available on your on-prem self-hosted gateway, and then you can call them there. So that's pretty cool. But how do you add Dapr to this? Well, the API management self-hosted gateway, and of course my own customer service, that could be a service that I created, I can install them, or I can add a Dapr Sidecar to them when I deploy them on Kubernetes, just as we saw with traffic control. So the Sidecar is added, and then using the Sidecar, I can use these special policies that were created for Dapr to integrate this into my solution. So first of all, let's look at the /customer endpoint. So if we look at the policy for that, you see that there's a way to use Dapr because I set the backend service for the call. So before I called directly into the customer service, but now I say the backend ID is Dapr. I give it the Dapr application ID, so that is the unique identification of the customer service in this case, that is registered with Dapr when it started, and I specify the method that I want to call. So in this case, the add customer method on the customer service will be called. And this is quite simple. So I'm just using the Dapr API over HTTP or gRPC, whatever is best in this case, and I call the customer service through Dapr. So that is how that works. Another, I think, more interesting way of using Dapr is when we look at the customer created, because this is more of an event type API. And there is a specific publish to Dapr policy created for creating these kinds of interactions. So if you look at the policy in here, you say publish to Dapr. You specify the name of the PubSub component that you want to use. So this is configured using the building block configuration, just as you saw Sander do in his demos for security. You specify the topic that you want to use for the messages, and you specify the content type of the body in this case. And in this case, I'm just using application JSON. And then finally, you can also return a variable, or you can use a variable to store the response that you can send back if the operation sends something back. So if you can see in the picture here, so when I call this API now, the Dapr sidecar of the API management self-hosted gateway will post a message on Redis. In this case, we're using Redis because that is what we configured as our message broker. And then the customer service will, through the Dapr sidecar, create a subscription on the same topic that it uses. In this case, that is customer events, and it will automatically receive these messages. So with this, you have created an asynchronous message flow directly from API management to your backend services, which is pretty cool. And you don't have to know anything about Redis or whatever. It's just Dapr doing all the heavy lifting here. So I won't do a demo for this, for sake of time. So I will dive directly into Logic Apps integration. A little bit of the same scenario here, but then with a different Azure service, because Logic Apps is basically a workflow or integration tool that we know from Azure. And also Logic Apps, you can run these nowadays as a self-hosted Logic Apps runtime anywhere you want. It's also just a Docker container that you run on your own machine or in your own data center. And just as with API management, Dapr can integrate with this self-hosted runtime. And then you can trigger a workflow using Dapr. So you can just do an invocation on the workflow on the host, and it will start a workflow instance that you defined. But you can also communicate with other Dapperized services from your workflow. And I will show you how that works. So first of all, this is the workflow, the demo workflow that I'm going to use. So it basically receives an HTTP request. This is when I call into the workflow. It then calls another service to get some owner information, just as you saw in the traffic control demo. Then we create some kind of a vehicle record that combines the information that was in the HTTP request with the owner information. It stores this information in an external store using state management, and then it will send a response with the vehicle information. So to dive into the details how it works, so I can now, when I run this on my machine, so I have started the workflow, I can just call into the Dapr sidecar of the workflow host and use the invocation, service invocation building block to say, okay, invoke workflow/method, and then the name of the workflow I want to start an instance of. So this vehicle registration that you see here as method name, that is exactly the name of the workflow definition that it will use to create an instance of this process. And in the payload, you see some information of a vehicle. Then from the workflow, I can use an HTTP action. So basically, I'm just doing an HTTP request outbound from the workflow. But because I'm using localhost 3500 and I used, again, the service invocation building block, I can just use another or call another service within my solution using Dapr. I don't need to know where it lives. I just call my own sidecar, and then it will send a request to that service. So here you see that I'm getting the person information for a certain owner ID that I passed in the request. Well, this is what this looks like in workflow. So you can just drag and drop this together, and this will just do an HTTP request, and I pass in the owner ID as one of the query parameters. So when this comes back, this contains some data. In this case, Miss Audrey White. It's just a random name, of course, because it's a demo. Then we create a vehicle record. So from the information that was passed into the workflow, combined with the person information, we create a composite record. And then we store this record in the state store. And storing it in the state store is, again, the same story. I can call the state management API, as you can see here. It's localhost 3500, then state, and then the name of the state store that I want to use. And then Dapr will, again, take care of all the heavy lifting and will store this in the state store that is configured. And then finally, if everything works out great, we will get back a response. So this is how this works when we look at the workflow. This from the workflow, how I can invoke it and how I can invoke other services and other building blocks through the Dapr sidecar. So what does this look like as we look at the components, so all the running parts here. So this is what I have deployed on my machine. If I want to use this, I have a workflow host that has a Dapr sidecar, and I have, in this case, my external person service that also has a sidecar. And when I start this, so if I create this, it will automatically load the workflow definition that I specify. So I have a couple of workflow definitions that it can load. In this case, it is the vehicle registration workflow. And it will also register this workflow in the table storage, because workflow will have storage of its own for storing the workflow state and etc. And it will create these tables. So when we look at a little bit of code, this is the sample solution that I just described, and I won't be going through all the code and everything. It is also up on GitHub, so we can share the link if you want. But if you look, for instance, at the person service, it's a very simple service. I can do a get owner info. It will get the owner ID as a query string parameter, and then I just generate a random name, because this is a demo, right? And then return this. So it's a very simple service. But also very interesting is the workflow host definition. So this is a Dapr configuration file, which basically defines, or sorry, this is a Kubernetes manifest file that describes how to run the workflow host. And as you can see here, I just annotated this workflow host container with some Dapr IO annotations. And this will make sure that the Dapr sidecar is injected with this container. So that's basically all you need to do to get this to work with Dapr. So that's pretty easy. So let me start my solution here. So what I'm doing now is that I'm deploying the workflow host and my person service onto my local Kubernetes cluster. And if you now look, for instance, in the Azure table storage that I have as backend storage, and I refresh that, then you will see that a couple of tables were created for storing information about the workflow. So this is basically the state of the workflow that's automatically persisted in the backend store. This has nothing to do with Dapr, right? This is just running a workflow instance on your machine. So what I can then do is if I now send a request through Dapr to the workflow host, which is basically just an HTTP request with a JSON payload, it will be delivered using service invocation to the workflow host. And this will automatically start an instance of this workflow type. So in this case, the vehicle registration. And this, what you see on the right, is just the flow that I just explained to you. So what then happens is it will start calling the person service to get the owner information. And this will work like this. It will call the Dapr sidecar. The Dapr sidecar will find the sidecar of the person service using its application ID, and it will do the request and return the response back to the workflow. Then we can create the vehicle record. And when we store this record in state store, we will call, as we saw in the example, the sidecar, and the sidecar will eventually store this in table storage. So let me show you how to do this. So my workflow is working now. What I can do is I can look into my Kubernetes cluster. So now this is a tool for looking at my Kubernetes cluster that's running in Docker Desktop. And if I now go to the person service, we see the workflow host and the person service here. If I go to the person service and look at the logging of the service, you see this is just a .NET service, just a .NET API that is waiting for requests. And what I can do now is I can create a request. I can send a request using an HTTP client on the workflow using Dapr. So I do Dapr invoke workflows, and then the method is and then the name of the workflow, just as I showed you before. And here you can see this payload with some random information in it. And if I send this request, you also see that I get back all the information. So I get the information that I passed in, but also some information of the owner, in this case, Gonzalo Magel. And you also see in the logging of the service that the person service was called. So you see that actually the call was made from the Dapr sidecar to the person service. And if we now go back to Azure Storage and we look in the vehicles table and we open that, we actually see that it stored this record with all the information, including the information of Gonzalo Magel, into my my table storage. So this was done using the Dapr state management building block into Azure Storage. So that's it. This is how you can integrate Dapr with API management and logic apps. There's also a very tight integration into Azure Functions, but we don't have time to look into that today. But it's also very promising, so you can use Dapr to trigger, but also use output bindings from functions to call other kinds of systems. So that's something to look into if you're interested in that. So with that, I will stop sharing my screen and then pass it back to you, Sander.
Yeah, that is perfectly fine. So let me share my screen for the last part. And in this section, I guess you can, I need to click the share button. Okay, so in this last section, I will show you how you can extend Dapr by creating your own custom components. And for that, we are going to create a binding component. So bindings are used to interface with external systems. So it's basically similar to Azure function bindings. So it kind of abstracts that that external system, so you don't need to know all the intricacies about how you need to call it. So you don't need to know how to use the APIs or SDKs. You just need that simple binding, and the binding does all the hard work for you. Now, this is going to be a bit of an exciting demo for me, because I usually demo this by creating a file system output binding. But unfortunately, or fortunately, it depends on how you look at it, Dapr now comes with a file system binding out of the box. So that's great if you need a file system binding, but it's a little bit less great for me because I want to have a different binding as a demo than what's already in the box. So I needed to think of something else, and what I came up with is to create an output binding for my Philips Hue lights. So as you can see in the back here, I've got some lights, some colored Philips Hue lights turned on. And I want to see if I could create an output binding that would switch the scene so that these lights behind me would change their color. Now, I've only built this last late night, so I hope this is all going to work out. So here's what we will do. We will create a output binding component that contains all the logic to interact with the Philips bridge and send the correct requests. And then if you want to use that binding, you would need to have a component configuration file, like any component in Dapr. And that's going to look a little bit like this. So I'm naming this component my study lights because I'm in my study room right now. And I wanted to be able to use a bindings.u, which we are going to create, and then I will need to give it some metadata, which I will dive in later on. And with that set up, we should be able to invoke a binding like this. So bindings are invoked by making a call to the sidecar at the bindings endpoint, and then you give it the name of your binding. So in this case, study lights. And then in the post body, we need to send two parts, and the operation, because bindings can support multiple operations. So for example, I could also have implemented a list operation to give back all the lights that are in the study room. But in this case, we will only implement a single operation, which is called switch scene, and which will switch the lights to the scene with the given ID, which is in the data field. So if we perform that request, then if all goes well, my lights behind me should change their color. So that's the plan. Okay, so what do we have to do if you want to extend Dapr? Well, Dapr itself, as well as all of the components, are written in Go or Golang. And there are two basic Git repositories that you need to concern yourself with if you want to contribute components. The first one is called components contrib, and that repository contains all the code for all the components in Dapr. So that's where you create a pull request to add your custom components to the to Dapr. But you also need to make a small change in the main Dapr repository, because the Dapr runtime code depends on all of these components. So it's a two-step process. You need to add your component code to the components contrib, and then you need to add your component registration to the Dapr repository. And how this works is that at build time, all of those components and the Dapr code is combined into a Dapr executable, and that's the executable that actually runs inside your Dapr sidecar. Okay, so that's the theory. Let's actually do this. Okay, so I'm over here in Visual Studio. You can see on the left side that I've cloned both those repositories. I've got Dapr installed on my machine here. I believe, yes, it's version 1.0. We're actually at version 1.1 right now with Dapr, so it's time for me to upgrade. I've also got Go installed. So let's start by adding the actual code for the binding. So I need to go into components contrib. there's a bindings directory here where you can see a directory per binding. So I'm going to add a folder for my own binding. Let's call it U because it's Philips Hue lights. And then let's add a file to that. Let's call it u.go. And now I'm going to type really fast. So let's get some code in here. So this is basically all the code that I need because it's not really difficult to control your Philips Hue lights. But for each component that you need to write, there are basically 3 important functions that you need to implement. And the first function is this initialize function. So this function is called when your component is first being loaded by the Dapr runtime, and it will pass in, or the Dapr runtime will pass in the metadata that it loads from the component configuration file. And so as you can see here, I'm expecting the user to specify at least 3 parts of metadata in the component configuration file. I need to know the location, the IP address of the Philips Hue bridge, because that's the device that I need to talk to change the lights. That the access to the bridge is controlled by a username, so I need a username in order to access the bridge. And then I also want to know which group of lights are you trying to control. So a group is basically just a logical grouping of lights in your house. I've got a group named Werkkamer, which is Dutch for study room, and I will use that. Then the second function that you need to implement is this operations function. So this will return a list of operations that this binding supports. And in this case, I'm only supporting a single operation, which is called switch scene. And then probably the most important function is this invoke function right here, which actually executes the real business logic that you want to execute whenever this binding is invoked. So what I'm doing here is I'm getting the name of the scene or the ID of the scene from the request. And I'm also getting all that configuration data from the metadata and to create a URL. And then I basically create a request to send to the U bridge, and I perform that put request, and that the U bridge should change my lights. So that is a pretty simple implementation. Okay, now with that all set up, we can go over to the Dapr repository, and we can register this new binding. Registration needs to be done over here in command dapr main.co. And you can see here is that this is basically a file with a long list of all the components. And so we first need to import our component, which we should do over here just to keep it nice in alphabetical order. And then if you scroll a bit down, you can see that there is code here where all of these bindings are instantiated. And we also need to include our binding in this list. So again, just for my OCD, I need to put this in alphabetical order. So with that out of the way, I should be good to go to now build this local copy of the Dapr daemon and try it out. Except that if you carefully look at this reference that I've added, I'm referencing github.com. But my component, I'm still building it, and my component isn't up on github.com yet. It's still on my local machine. So this build, if I start it now, it will fail because it cannot find its component up on GitHub. So I need to make sure that instead of the build using all those GitHub links, it will redirect them to the GitHub or the repository clone I've got on my local machine. And I can do that. Let's cancel that one. I can do that using this command, go mod edit, which basically replaces all those references to point to my local copy. So if I do that, and Go is really working my machine hard here. Some stuff going on with the Go language server, so this will probably take a couple of seconds to work itself out. So let's just wait for that to finish, and then I'll explain what we're going to do next. So once this command is done, which should actually just complete within a second, we will build the Dapper daemon, and then we need to copy it over the official Dapper daemon, because Dapper daemon is installed in a certain place where it has its configuration files and stuff. So we will make a backup of that original file, then copy our new one over that, and then we can run it. So let me start the build process here. This will also take about a minute, but fortunately we can just cut it off once we have our Dapper daemon, because this will also build other executables like the Sidecar injector, which is used in Kubernetes to inject sidecars into your pod, and the Sentry system servers that I talked to you about in the security part. It will build all of those components, but the only one that we need right now is just the Dapper daemon. So this will probably only take a couple of more seconds before we have that, and then we can go copy and run that. Maybe in the... Yeah, so, and I'm hearing in my headphone that it's time to queue for Q&A, so I don't want to cut that short, so I'm going to wrap this up fairly quickly. Let me just create, oh yeah, okay, so this is done. So let me interrupt that build process, and I need about just 1 minute to show you the result, and then we can go into the Q&A. So let me actually make a really quick backup of my original Dapr daemon, and I copy the new one over it, and then we need to create a configuration file that I talked to you about. So it will look like this. It's basically the configuration file that I showed you on the slide, only now it has those metadata filled in. And with that all set up, I can start running this. So I can do a Dapr run on port 3500. And then I've got some demo requests set up. I should be able to call, and just so you can see those lights a little bit better, excuse me, that's not what I want to do. I want to put it here, just to make sure you can see those lights changing. Let me just open a window. Well, I can't seem to get to QuickTime right now, but you can see it on the, come on. You can see it on the on my background, I guess, because I should be in the screen large enough. So if I now send a request to that binding, give it the operation switch scene and give it the new scene ID, then now everything seemed to have worked fine, luckily for me. So now it should be the colors of the Russian flag behind me. And I can switch that back to presentation mode just by calling that binding again, but giving it a different scene ID. And you can switch between the two. Now, obviously, controlling ULights is not something you would typically do from a distributed microservices application. But if you want to create a component that actually does something useful for your enterprise or your organization, the steps that you have to take to build that component are exactly the same as the steps that I've just shown you. So with that, I will stop my screen share.
You can just go to the last slide.
Oh, I could go to the last slide, so I will share that again. Go to my PowerPoint, last slide. So yeah.
Yes. So thanks everyone. A little bit over time. You had some. I think you had some network troubles, Sander, for getting the Go libraries. But yeah, let's go into the Q&A. We've already answered some questions in the Telegram, in the group chat. So
okay, great.
So I don't know if there are any questions from the audience.
And I also wanted to plug this Dapper workshop once again, maybe.
Yeah.
So if this has been more about some of the advanced topics. If you're still pretty new to Dapper and you want to get some more or better understanding of the basics, as well as some hands-on experience, please join us tomorrow for the Dapper workshop.
So I don't see any questions appearing in the Advanced Dapper stream or the Advanced Dapper chat, but
Do you hear me, guys?
yes.
We hear you, Yuri. It's a little bit low volume, but we can hear you.
Yeah, it was some problems with my microphone. Well, thank you. Useful and interesting introduction to advanced basics to Dapper, and magic with lights were awesome, really. Well, we have a questions, and the first question I want to ask about this light magic. You showed, Xander, you showed that you cloned the Dapper repository and added there your source. Well, and are there any? Well, can we push our changes to main repository, or should we build it from our own repository? Will guys who is maintaining Dapper accept merge requests or not?
Yeah, so there's a group of maintainers who are currently maintaining Dapper, and they are really open for your contributions. So it's a really open, very cool community. So what you usually would do if you want to create a component, and I think Edwin actually went through this because he submitted what was it again?
SMTP component, yeah.
Yeah, an SMTP component for sending email. Is you basically go through the steps that I've shown you, just do it locally for your development. And then once you've got something that you think might actually be useful for other people to use, then you can create a pull request on the contrib repository and the Dapper repository. And you will get back probably some review comments and some suggestions from the maintainers. And once that all works out and the quality is good enough, they will merge it into the main product. And from then on, it will just be in the product.
Yeah, and in the components contrib repository, there's a very nice contribution guide that explains exactly the tools that you need and how this process works. So it's all been described in the repository itself. So it's very nice.
Well, great. Thanks, guys. And one more interesting question. Are you using it in production environment, and what is your real experience? What problems or difficulties do you have?
We haven't have any customers that are using it in production because it's very early on. The version 1.0 came out in February, so it's really early days. So we haven't used it in production yet. We have some proof of concepts now running for customers, and I must say that if you just use Dapper for what it is used for, so then it works fine. But we often see people trying to misuse Dapper for things that it wasn't created for, and then you can run into some problems. But the product itself basically does what it says that it should do. So we haven't seen any real issues. And also we have also did some contributions to Dapper itself. So you can also, if something is broken, you can also fix it yourself and then also contribute it back to the Dapper repository. So that's also a possibility, but no production workloads for us for now. There is a reference case by Microsoft. I think it was Zeiss, Carl Zeiss, the lens manufacturer, and they're using Dapper extensively in a production application.
Yeah, and one thing, if I may add one thing to that, is that one of the benefits of Dapper is that it's completely up to you if you want to use all of the building blocks or just a single one of the building blocks. And one of the pitfalls is that when you look at how can I apply Dapper, that people tend to want to use all of the building blocks. And hey, there's an actor building block. Oh, we should use actors. How can we shoehorn actors into our solution? Yeah. So that's one of the pitfalls. Just really have some sensibility about it. What kind of building blocks are a right fit for the problem that I'm trying to solve?
Okay, well, when we're talking about microservices and the Dapper, does Dapper ready for high load solutions?
Yes.
And what are performance gains of this?
Yeah, it's all written in Go, right? So there's very high emphasis on making sure that all the code that is committed is very performant. So, for instance, when I created the SMTP binding, I got some review comments that I did some string conversion from a string to an int somewhere in the code, and they just said, well, take that out of the main code and put it into the configuration step, so we don't have to do it every time. So they're really keen on making it all very high performant code. Also, of course, there's always a performance impact from using the sidecar pattern, right? Because you're going to have to do an additional hop when you call something. But also, this performance is really scrutinized. So there are all kinds of automated tests, and also in the documentation of Dapr. As you can see here on the slide, if you go to docs.dapr.io and you search for performance tests, you can also see the performance characteristics of the sidecar. So they do testing whether or not the performance increases or decreases with every release. So there's much emphasis on performance, as I've seen until now.
Okay, thanks. Well, when we're talking about microservices too, we should have centralized monitoring and centralized logging. What can Dapr give here to us?
Yeah, well, that's actually a good question, and that's one of the things we couldn't even do in this session because it's just the top of the iceberg. But yes, Dapr also includes very extensive monitoring capabilities. So because all the communications through all the services is used or is done by Dapr, you have, for instance, automatic end-to-end tracing. And this is all these kinds of logging and tracing information is made available in open standards like OpenTelemetry, and you can use tools like Zipkin, which is actually installed with Dapr if you install it on your machine. But you could also use, for instance, ElkStack and stuff like that. So yeah, there's lots of observability in there.
Sorry,
Sounds
Edwin.
good, guys.
Yeah, just wanted to interrupt you guys because it's already time to go to Zoom. Yeah, please follow to discussion zone and understand that there are a lot of questions to discuss. And I also want to kindly remind all the guys that tomorrow you have a workshop on the first track. So please, guys, join Edwin and Xander in this workshop. Thank you, guys.
Thank you.
Thank you, guys.
Thank you.